Go.
Alright, here's our givens for our Laplacian with polar coordinates. So we're going to start with UR equals ux times xr plus uy times ur. And then u theta equals ux times x theta plus uy times y theta. UR equals uxr times xr plus uxr or plus ux times xr plus uyr times yr plus uy times yr. And for u theta theta, we have u x theta times x theta plus ux times x theta theta. Uy theta times yr or y theta plus uy y theta. So just the same as u r, but with thetas. Then uxr equals uxx times xr plus uxy times yr. Ux theta, same thing, thetas, ux x theta plus ux y theta. And then we're going to do the same thing for u, yr, and y theta. Alright, so here we go. And then for our partial derivative givens, we're going to have xr equals cosine theta and then x theta equals negative r sine theta. And for yr and y theta, we're going to have sine theta and r cosine theta. xrr equals 0, x theta theta equal to negative r cosine theta, yrr equals 0, and y theta theta equals negative r sine theta. All right, so now that we have all this down, we can start with our steps to start getting our Laplacian with polar coordinates. So for our very first, we're going to start with the basis, which is urr plus 1 over r ur plus 1 over r squared u theta theta. And this is going to be equal to uxx plus uyy. So our first insertion, I guess we're going to do is we're going to start subbing in our ur's into this equation. And so here for urr, we're going to sub in our constant that we have from over here, which is uxr times xr plus ux plus times xr plus uyr times yr plus uyyrr. And then we're going to get to our plus 1 over r we'll leave this ur for now, and plus 1 over r squared u theta theta. Alright, here we're going to sub in our other urs and our u theta theta here. So here our ur is just going to be uxxr, or ux times xr plus uy times yr. U theta theta, we're going to have plus 1 over r squared which is going to be ux theta times x theta plus ux x theta theta plus y theta y, or y uy theta y theta plus uy y theta theta. So now I have everything subbed in, and what we want to do next is we're going to, so now we've expanded and we put in our xr's and our partial derivatives, and so now we're going to expand it even further and put in our uxr's and our uyr's. And so now we'll just write a completely new equation. So we're going to start here with uxx times xr plus uxy times yr close this parenthesis here, multiply that by xr plus ux times xr plus uyy times yr plus uyx times xr. Alright, and then next we're going to multiply this by yr. Just move past this line. Plus uy plus 1 over r ux xr plus uyr plus 1 over r squared ux theta times x theta plus ux times x theta theta plus u y theta times y theta plus uy times y theta theta. Go a little upward there. Oh well. Alright, so now that we have all of these plugged in, we've expanded our equation. Now we're going to start plugging in for our x thetas and y theta partial derivatives. So x theta, y theta, we're going to start plugging in these. And I'm not going to rewrite this whole stuff here. So we're just going to find where our x thetas begin. And this is going to come in our 1 over r squared section of our equation here. And we'll just bring this down. So uxx times x theta plus uxy y theta times x theta. We'll close this parenthesis here. And plus ux times x theta theta. theta plus uy y theta theta. Alright, so now that we have all this down, we're going to go back over to our partial derivatives, and we're going to start subbing in our our xr's and our yr's, and also our y thetas and yrs. And for this, I think I will just rewrite the equation here. So we're going to have uxx times cosine theta plus uxy times sine theta we're going to multiply this by our cosine theta here from xr plus ux times xrr plus start our new uyy here. So u yy times sine theta Actually, I skipped a step. I haven't done my R. Yeah. Okay. So actually just gonna multiply this by cosine theta plus ux times xrr plus uyy sine theta plus uyx cosine theta that'll end that. And then moving over to the right side of our equation here, we'll have, I'm going to start shooting this down here. Alright, so sine theta plus uy times yrr plus 1 over r ux cosine theta plus uy times sine theta. Plus 1 over r squared I'll move this down to a second line because this is 1 over r squared equation is long. Uxx times negative r sine theta times negative r sine theta. Plus u x theta theta plus uyy r cosine theta plus uyx uyx times negative r sine theta times r cosine theta plus u y times y theta theta. Alright, so this is what we have up to this point. It's this whole equation here before we start inserting our second partial derivatives, our xr's, yr's, x theta thetas, and y theta thetas, which is what we'll be doing next. I'm going to erase this just to give me more room to work with up here. But we're almost getting to the fun parts where we can start canceling stuff. All right, so now we're going to start subbing in our second partial derivatives. We're going to start with x. Try to keep our lines straight this time. It's getting kind of messy. Cosine theta plus uxy sine theta cosine theta plus ux, and then we're going to be multiplying this by 0 because that's what our second partial derivative is going to tell us. Plus, which is going to end up canceling this whole section here. Plus uyy sine theta plus uyx cosine theta times sine theta plus uy times 0. If you notice, these two sides are starting to mirror each other, so we're starting to match up the way we want to be. Plus 1 over r x ux times cosine theta plus uy times sine theta plus 1 over r squared uxx times negative r sine theta plus uxy r cosine theta. negative r sine theta plus uy negative r sine theta. Alright, for our next step here, we're going to be sort of distributing our cosines and sines just so that we get all of these to be a lot simpler. And then after that, we're going to distribute one of our r's to be underneath all of ours, just so that it looks cleaner and it'll be a lot easier to clean up. So we'll have u of x cosine theta sine squared theta. Plus u xy sine theta times cosine theta plus u y sine squared theta plus uyx cosine theta sine theta. Plus uy sine theta. 1/r². X negative r sine theta squared plus uxy sine theta cosine theta take the r cosine negative r sine. There. Plus negative r sine theta, r cosine theta. Plus uy negative r sine theta. And then next, we're going to keep this first term here. This is going to remain constant. But we're going to put our r's here underneath of our other terms. Just going to have ux cosine theta over r plus uy sine theta over r. Yeah. We're going to have x times negative r sine theta squared, or r squared, plus uxy r cosine theta times negative r sine theta plus uxy, or wait, just ux here, negative r cosine theta. R cosine theta squared over r squared again. Uxy negative r sine theta, r cosine theta. Plus uy negative r sine theta over r squared. So now we have all of these denominators showing, and it'll just make it a lot easier for us to find our common terms. Let's cancel them out. And so what we have left here is, once we actually distribute these squares here and these negatives, we're going to be left with like a negative here, a negative here, a positive here, because it's going to be squared, and then a negative here, and these are all going to end up canceling out. And so our next term is going to be uxx cosine squared theta plus uxy sine theta cosine theta plus uyy sine squared theta plus uyx cosine theta sine theta. And these are all just from our constant term that we had before. And then getting into our over r's here, we have ux times cosine theta squared theta minus u x y cosine theta sine theta this is actually supposed to be a negative minus u x y and minus u x cosine theta over r plus u y cosine squared theta minus u x y sine theta cosine theta minus u y sine theta over r. And so here everything should cancel except our uxx's and our uxy's, so we can cancel out our positive uxy and this negative. We should have another negative uxy here that's going to cancel out with hopefully uxy over here. We have this right here. And so now we're left with our uxy's and our uyy's and our uxx's over here. We're going to find our ux over r here, cosine times theta. Yeah, these should be two separate terms, but either way, it's going to end up being the same as this canceling with this and this at the same time. And so now we're left with our, I guess this should have canceled also. Am I missing one? Our uxy sine squared. Oh, this, never mind. No, this is my uxx. I just had bad handwriting here. All right, cool. So getting pretty close to the end of the tunnel here. We have our uxx times cosine squared theta plus uyy times sine squared theta plus uxx sine theta sine squared theta plus uyy cosine squared theta. Alright, so here you can see pretty much everything's lining up. What we're going to do is we're going to combine our uxx terms, our uyy terms into one sort of conglomerate where the sines and the cosines are going to combine so we can get our favorite trig identity here. We're going to have uxx sine squared theta plus cosine squared theta, which is going to end up equaling 1 plus uyy sine squared theta plus cosine squared theta, which is also going to end up equaling 1. And so now we have our uxx and our uyy multiplied by 1, which is just going to give us uxx plus uyy. So this is going to equal our, what we said at the very beginning, which is it's going to equal itself, uxx and uyy. All right. That was fun. Is my phone dead yet?
Can I turn it off?
Yeah.